Are barreling towards the end of chapter 2. We're in section 2.7, combining functions. So we can combine functions. We can add them, we can subtract them, we can multiply them, we can divide them, we can compose them with each other. And these are things that we might do to help us out with something. So let's just kind of remind ourselves that we can do this. So let's take a basic function, x squared. We're also going to take another basic function, 2x minus 1. And when you see this function notation here, like in example A, f plus g of x, that's how it's read, it's just the same as f of x plus g of x. They mean exactly the same thing. There are just two ways to write it. But when you write it that second way, you can see that it becomes very simple to see that all you need to do is take the two functions and add them together. And that is literally the answer. So if you'd like, you can pause, see if you can answer any of the other ones. Take a moment. You could actually do E right now because of what we did in A. But just see what you can do. Hopefully there's some aspect of this that is some review for you. Pause now. Okay, so the only difference between adding and subtracting, of course, is that when you subtract two functions, especially if the second one has more than one term, you do need to think about the distributive property, so don't forget that. So notice that f of x minus g of x is different than f of x plus g of x in this case. So we have this. F of x times g of x, so f times g of x, two different ways to say that, is just as you would think. That's a multiplication sign there, that little dot. So it just means take your x squared. I guess I should start with that just to be consistent. So I'm going to take my x squared, I'm going to multiply it by 2x minus 1. Sure, if you wanted to, you could multiply that out to get 2x cubed minus x squared. That is a valid answer as well. In terms of dividing, you really would find that you get the same. It's exactly what you think, f of x divided by g of x. Often there's not a lot you can do once you do this. You're literally just doing this. The only thing that you'd have to think about is the fact that now that you've done this division, do make sure you kind of pay attention to the fact that you have a domain issue there. The domain is not all real numbers. The domain has a restriction. X cannot be a half. That's going to give you 0 in the denominator. Just a side note, just so that you know. When you have f plus g of negative 1, know that it is the same as f of negative 1 plus g of negative 1. That's a true statement. You could add the two functions together, plug in negative 1. Or you could plug negative 1 into each function and then add the two numbers together. You get the same thing. So notice I said something about if you've done A, you can do E, because if you plug in negative 1 into what we found in A, because A was already the two functions added together, we get 1 minus 2 minus 1, and then we just combine them. So we would end up getting a negative 2 for the answer there. Similarly for f, you're doing f times g of 2. Since we did already find the answer to that, so maybe I'll do some arrows there if that helps you out. You can see that now we can just take what we found in part C and we can evaluate that and see what we get. So we're just plugging in 2 everywhere where we see x. Looks like we get 16 minus 4, which is 12. Remember that this is the same as f of 2 times g of 2. You could do it that way as well. So big thing there, you can add, subtract, multiply, divide functions. When you do divide them, you do have to pay a little bit of attention to the domain, but that doesn't mean that you don't just put f of x over g of x. Now, a kind of bigger thing that comes up later in calculus when you use the chain rule, spoiler alert, is the composition. So the composition of two functions looks like this. Sometimes it's literally called fog. You might see that. But it's by definition f of g of x. So that's how we say that, f of g of x. And what it means is to take g of x, whatever that function is, and put it into your function f of x wherever you see x. That's the idea. And typically, f of x, f of g of x, and g of f of x are not equal, typically. So we're going to use the two functions from before. So I'm going to write this as f of g of x. And I'm going to need to take a look here to remind myself what the two functions are. So the first one is saying take g of x, place it in where you see x in f of x. So f of x is just x squared. So I'm going to write it like this. And then instead of squaring x, I'm going to be squaring g of x. So you know what? I'll do this an extra step here in case anyone would like to see it. So what it means is we're doing f of g of x. So we're doing f of g of x. G of x, again, from above is 2x minus 1. So I'll do an intermediate step there. So it's saying take 2x minus 1 and place it into the function f where you see x. So since that is, f is x squared, we're going to replace x with 2x minus 1. And that's it. That's it. Now, I'm going to go straight to C. I'm going to mix it up. I'm going to go rogue here in my notes, and I'm going to do C next because this is f of g of 1, and that simply means you take what we've already done, which is f of g of x, and then you just evaluate it at the value 1. So we already have what we need. We're just going to replace the x with 1. So let me come here. Just like that. So maybe I'll write it here so you can see. We're putting that 1 in where we see x into the fact that we've already done that composition. So it looks like we're going to have 2 minus 1, which is 1 squared, and that's just going to give us 1. So if you would like, I would really like it if you could pause this and do B and D so that you can see the answer to that and kind of work it out yourself. So, like I said, g of f of x is not going to necessarily be the same as f of g. It's actually only the same in very specific cases. So, when we do this, we're going to go g of f of x, and we know already that f of x is x squared. So, it's going to be g of x squared. Now, for us, that means 2 times x minus 1, where the x is now being replaced with that x squared. X squared. So that's the x squared. And not a whole lot you can do. So 2x squared minus 1. That's it. But now it allows us to very quickly do part D, which is g of f of negative 2, meaning go ahead and take that negative 2 and put it in where you see x. Answer should be a number. That's the idea. So I'm going to make this blue so I can color code it for you there. Negative 2. And then you just evaluate. You just write it out. So go ahead and do that if you haven't already while I'm messing with my pen here. So it looks like I'll have 2 times 4 minus 1. And that's going to give me 7. And that's the answer to that. Now, if we wanted to go backwards, so instead of composing two functions, we wanted to kind of decompose them. I just want you to take a look at one example here, because we do a lot more composition than we do decomposition. But if you take a look at h of x, you should see that there's this function here. And you can look at it as a composition of two functions. So let me write over here, let's think of this as f of g of x. So it should tell you that your g of x function is whatever you have that's kind of the inner function. Typically it has some aspect of being inside. And the f function is the function on the outside. So hopefully you can kind of see here that when you're given this function, there's a part that's more inside and there's a part that's more outside. And for most students, they can see the inside part pretty easily. They say, well, the thing inside the parentheses is this. But then we have to think about what is the outer function? And when you're wanting to ask yourself the question of how to find that, the question should be, what would I need to have for f of x so that if I were to put 3x squared plus 2x into f of x where I see x, I'm going to get this full function here. That's the idea. So what you hopefully can see is that the only thing that we really have not done so far is dealt with that exponent, that power of 10. So that's what we need. We need something to the power of 10, but it's simpler than you think, because if f of x is x to the 10th, then when you do the composition and you place 3x squared plus 2x in for x, well, then you have your h of x, and that's what you're doing here, is writing it as the composition of two functions, outer and inner. Okay. Now, the last thing for this section, it is fairly straightforward, hopefully for you, is to find two more compositions. So f of g of x, if you can do that, and if you can do g of f of x. So take a moment, see if you can do those two, pause and see if you can do them, and then come back. Okay, so I'm going to try to use a couple colors here. Okay. And then notice I'm going to place g of x into here, and I'm going to place f of x into here. Okay, and then I'm just going to simplify each one. So my 2 simplify, we get x. Over here, my 1 simplify, we get 2x over 2, and that equals x. So g of f of x is the same as f of g of x. And even more than it being the same, both of our answers are x. Very, very soon, you're going to learn that this is a case of two functions that are special. These functions have a special aspect to them that we'll talk about in section 2.8. But that is section 2.7.